Hey everyone, my name is Tristan Babet. I am a postdoc at Stanford University, and I'm going to give you now a quick overview of the poster for Task 4, just to help you to navigate the different contents. So in Task 4, our objective is to develop reactive transport modeling tools to simulate colloid-enabled transfers and reactivity. So this Task 4 directly builds upon our previous modeling work on column experiments, where fine-grained organic carbon-enriched lenses were embedded inside coarser-grained aquifer material. So you will find here like a schematic of the experiments, and here a quick description of the model, and here in this center column, the main results of the numerical simulations. A first interesting finding of this work was that reducing conditions really tend to spread from the fine-grained lenses into the surrounding aquifer material and to create secondary reducing zones that are highly susceptible to, for instance, a change in hydrologic conditions in the aquifer. Another interesting finding was that the variations that were observed in the solid phase, for instance, in organic carbon content or in reduced material like Makina white, those variations of concentration in the solid phase were not reflected in the aqueous phase. And this observation led us to hypothesize that a significant part of the transfers occurring between the fine-grained material and the coarser-grained material actually took place in the colloidal form. This hypothesis is supported by preliminary laboratory experiments that show that indeed colloids are exported from fine-grained material, even if we don't know yet what they are exactly and how many do we have. We also realized some preliminary modeling work where we implemented very simple representation of colloidal processes into reactive transport models. And this preliminary attempt also agrees with the idea of colloids as a vector of transfer for chemical species and for reactivity. However, this matter of integrating colloidal processes into reactive transport models still remained a very wide open question and wide open challenge. And so to address this challenge, we will work closely with the experimental work done in Task 1 and Task 3 to identify and to parameterize the important colloidal processes at work. So for instance, generation and filtration and precipitation. Then those important processes will be integrated into reactive transport codes, in particular by leveraging our collaboration with the DOE IDES program. Thank you for listening, and I will, of course, answer any question you might have during the review.